So let's review a little bit from yesterday. Yesterday we solved absolute value equations. Okay, they had to be split into two parts, but you can't just go split them right at the beginning. You first had to get this part alone. The grouping symbol has to be isolated. Get that alone. Go ahead and do this one right now on your paper if you haven't already. All right, I've gotten a little ways here. This is the important part now. What do I do now? Can't yet. There you go. Now and then I'll add 3. 2x minus 3 equals 5. Yep, and then I'm going to add 3 to both sides. And I'll get 2x equals 8, and then x equals 4. But when I split it, I have 2x minus 3 equals 5, and 2x minus 3 equals negative 5. And then I add 3 over there. And then I get negative 1 and 4. Are you positive that they're right? Not until you've checked them. Because sometimes you do everything perfectly, and it turns out that it didn't really work. So let's go back and check it. Stick in 4. Just do it with me. Just say it verbally. What's 2 times 4? 8 minus 3, 5. Absolute value of 5 is 5. 5 times the 3 is 15 minus the 5 is 10, and it worked. All right. And I'll save time by not doing the other one. You just have to stick negative 1 in, and you'll find out that it actually works. What if it doesn't work? Then we cross it off and call it what? Extraneous. Okay, good. There's a little review of yesterday. Now, today is similar, but different. Would you please write down the problem that you see in red on the board there? This says quadratic and absolute value inequalities. This one's a quadratic. Now, you may recall that there are 3 major ways we've been solving quadratics. There's actually 4, but there's 3 ways that we talk about a lot. And one is, first of all, you get this over to the other side, just like if it said equals. And you'd have x squared plus 6x plus 5 is less than 0. The only time you'd ever switch that sign is if you multiply or divide by a negative. And there's one other little moment where I'll show you where when you do have to switch a sign with absolute values. But back to this. I can factor this one, which is a great way to solve them. You'll see that we do that a lot. And we make your problems factorable. That keeps you from having to use the quadratic formula, which is one of your other ways. And the other way is graphing. Okay, so you could graph this thing, see where it touches the x-intercepts. You could factor it, or you can quadratic formula it. But factoring will work real nice. This is where if you can't factor just like lickety-split, then you're going to have problems in this class, because we do this a lot. Okay, so that's got to be the easy part. So now I got 2 answers. X equals negative 5 and x equals negative 1. Now, why do I have this number line here? Can I just be done? No. Because in a quadratic inequality, my answer isn't just like those are the 2 numbers that work. It's a set of numbers that will work. Like if I took a number line and had negative 5 on it and negative 1 on it, then either it's these numbers that are going to work, or it's these numbers that are going to work that are between this and this, or it's these numbers that are going to work down here. It's some set of numbers will work. It's sometimes 2 of the 3 sets will work. So how do we tell which ones work? Well, first of all, we got to check each area and see whether it works in that area or not. But the very first thing I should do is figure out whether 5 works or not. Should I fill in that circle because negative 5 works? Well, check. If I stick in a negative 5 here, then why did I even have a negative 5 in the first place? Because that makes that 0. If that's 0, what's 0 times 0? 0 times anything is going to be 0. So 0 is less than 0. Is that true or not? So that means that -5 does not work. -5 is a 0. It will equal 0. It won't be less than 0. So it's not going to work. And so is this. This was a 0. So it's also not going to work. If you really want to know if it works, you can always plug the number in and see if it works. But you can trust me on this, that if it says less than or greater than, it will never work. If it says or equal to, like this, then it will work, and we'd put a solid dot here, but it's not that way, so it's not going to work. Okay? Yes, sir. Yep. Yep. But they're just never going to work, so save yourself time. The only time they'll ever work is if this says or equal to. All right, so back to, I know the endpoints don't work. Now the question is it this section here that works, or is it this section, or is it this section? Well, we test each of them. And here's how you test them. You pick any number that's in that zone. Like the number -3 is in that zone. I could have picked -4, I could have picked -2, anything that's in that zone. And I'd go and stick it into this equation. You could go back to the original. It's just harder. It's easier to use this one. So I'm going to use this one. I'm going to stick in -3 and -3. Now in your head, what is -3 plus 5? 2. What's -3 plus 1? What's 2 times -2 make? -4. Is -4 less than 0? Yes, so it worked. So when I tested this point, it worked. That means everything in here will work. Now I got to test a point that's outside that zone. So what's a nice easy point to pick up in here? 0. 0 is a great point to pick. So if I'm going to test 0, I'm going to clean up my equation here, deleting off some of this junk. Okay, I'm going to test 0 up here and see if 0 works. So I'll put a 0 here and a 0 here, and I'll have, that works really nice, because then I just have 5 times 1, which is 5. Is 5 less than 0? No, so I cross that off. That area does not work. Now test this area, this little zone down here. It's things that are smaller than -5, like -6. I'm going to just forge and make this a -6. And now I have -6 plus 5 makes -1, and this would be multiply -1 times -5 makes +5. Is +5 less than 0? No, didn't work. So the moral of the story is I have to test these regions and figure out which one work. I can tell it works from here to here. How do I write that as an interval? You write -5 to -1, and you say it doesn't work at -5 and it doesn't work at -1. So that's my answer. The numbers that work are between -5 and -1, not inclusive of the endpoints. So basically the -5 doesn't work and the -1 doesn't work, but everything between them works. All right. I know I had a lot of steps, but it's really not that hard. Take this, factor it, find out what your answers are, put them on the number line, test this area and this area and this area, and one of them is going to work, or maybe 2 of them are going to work, and then you write your answer as an interval. Give it a shot right now. I'm going to hit pause while you work on that. Okay, we're back from the pause there, and it's x and +1 and +3, and that means your 2 answers are -1 and -3. So I go -3 here, -1 here. Do the endpoints work? No, not unless it has an or equal sign right there, and there is no or equal sign, so it's empty and empty. Does it work in between them? Well, I test the number -2. Let's see if -2 actually works. -2, -2. Here I would have -1. Here I would have +1. Positive times a negative makes a negative. Is that less than 0? Yes, it is. So it works in there again. And if it works in there, usually it doesn't work here and it doesn't work here. I have tested them in the last hour, so I'm not going to test them again. I know it doesn't work on the ends. I'll warn you, though, sometimes it does. Don't just assume that, oh, it's in the middle, so it can't be the ends. Sometimes it'll work on one end, not the other. So, but if I wanted to test one just to show you, if I test 0, 0's in that zone up there, I stick a 0 in here and a 0 in here, and I have 1, times 3 is 3. Is 3 less than 0? Nope, so it didn't work. Okay, final answer, -3, comma, -1. So the zone between -3 and -1, not inclusive. Raise your hand if you had that one right. Good. Moving on. This one, same idea, except splits into 2 parts. All right, split it into 2 parts, but do it with me. Go ahead and write the problem down. And draw your little arrows, 2 parts. I think it's good to remind yourself there's 2. X minus 4 is less than 1. You do it just like you see it. The other side's a little more tricky. Take a guess. It has to do with switching the sign, yes. So what should I write? X minus 4 greater than -1. So you switch the sign. Why? Because it kind of, to me, it's intuitive that if it's less than regular 1 and I change this to a -1, then I got to change the sign to be the opposite of what it was. To prove that it actually works, so we'll just do this problem and you'll see we got the right answers because we'll test the little zones. Okay, so then you add 4 to both sides. X is less than 1 plus 4 is 5. Add 5 to both sides. X is greater than 4. And now this one's kind of cool. I feel like I screwed something up there. Plus 4. You know what? Whenever I don't show my work, I make way more mistakes. You should learn from that. That your teacher even makes more mistakes when they don't show their workout. If you try to do too much in your head, you'll screw it up. I do. Here's 3. Here's 5. And now, the question is it things that are between 3 and 5? Is it things that are bigger than 5? Things that are less than 3? There's those 3 zones to test. Now, you could test each zone, but there's a faster way this time. You see how it says X is less than 5? So that means this number doesn't work. And unless there's an or equal sign there, but there isn't. So, but it says less than 5. And it says bigger than 3. So I'm guessing we'd shade that way. How can we test and be absolutely positive? Well, we stick in a 4. So I have 4. 4 minus 4 is 0. Is absolute value of 0 less than 1? Yep. So it worked. So we shade in there. And then we can test 6 and see if it works. Is 6 minus 4 is 2. Absolute value of 2 is 2. Is 2 less than 1? No, it doesn't work. So you test on each end, and you find out it doesn't work on either end, and your answer then is from 3 to 5 with parentheses. Raise your hand if you understand what I was just doing there. All right, good. And then there's one other kind of problem that we need to learn how. Well, I don't need to do another one of these, I don't think. Just split it into 2 parts, get you 2 answers, test where it works, in the middle or at the ends. Okay. Last thing I want to teach you for today then is linear regression. And it's actually pretty cool how you can use data from the real world to make predictions about the future. All right, let me give you, it doesn't have to be about the future. It can be just to make predictions. So here's how linear regression works. Would you agree that it would make some sense that a person who is taller would have longer leg bones? Does that seem reasonable? Do you think there's probably a direct correlation that the longer the leg bone is, the taller they are? Anytime you have that, that means you can write an equation for that. So let's do that for an example. Let's say that I had a person who, when we measure their leg bone, this is their leg compared to their height. You can picture that I'd have some length of a leg bone correlating with some height. Okay? As I get to a longer leg bone, I go this way, shouldn't they be taller? Generally, yes. So it's going to generally go up. Is it going to make a perfect straight line in the real world? No, because people sometimes have kind of gangly longer legs than they should have, but they just do. You know friends that have like really long legs compared to their body, or other, don't look at anybody, or people who have really short legs compared to their body, like the Fred Flintstone. Well, you guys even know who Fred Flintstone is, but anyway. So That's why the real world doesn't look like a straight line like that. The real world data is like this. But do you see it generally goes up? All right, and then you can write an equation for that, because if you pick any two of these points that make like that run right through the middle of your data, like these two, you can use point, the thing we taught you already, where you have 2 points and you can draw the equation for the line. First you find the slope of it, and then you go y minus y sub 1 equals, you can do all of that, but the calculator can do it way better. Because it doesn't even have to pick one of these points like this. It'll take all the data into consideration, and it'll tell you the equation for the line. That's to save you a ton of time, save you from having to find the slope, and then picking one of the points and putting in the slope point, and then solving it down for y equals whatever. Your calculator can just go, oh, y equals 1.37 x plus 22. It'll just do that for you. What do you have to tell it? You have to tell it the data points. So we're going to take a second here and measure a few legs and measure a few heights and actually see if we can get a correlation. We'll just get some data and we'll put it into the calculator in a second. Okay, so first we want some data. Leg, height. These are both going to be in inches to keep our units simple. All right. So I need a tall person. Who's a tall person who's not scared? All right, come on up here. And we are going to measure your leg length. So to keep this from being really awkward, I'm going to be measuring from your knee to your to the bottom of your foot. Okay. So would you put your, there you go, there, pull it up so I can see. I'm going to go from what I think is right in the middle of your knee. All right, that is 23 inches. His leg bone on the bottom part from his knee to the floor is 23 inches. Everybody write that down. Stay here for a second. 23 goes with a height of, including the shoes, so this isn't perfectly accurate, that's okay. Height appears to be 75 inches. Thank you, sir. Who's somebody who's kind of medium-sized? You're not really short, you're not really tall. Come on, don't be scared. All right, come on up. Thank you, sir. Now, if you can pull up that pants leg so I can see your knee. A little higher so I can see the middle of your knee. All right. I'm going to say for you, we're going with 21 inches. Okay, so 21 goes here. And your height. All right. Is, looks to be 69 inches, which is 5'9". Since you are kind of right in the middle, I think that's the average height for a guy in the United States, about 5'9". Okay, and wait a minute, 5'9". What did I say that was for inches total? 69 inches. So first of all, is this making sense that the leg was smaller and the height was smaller? Does that make sense? All right, now we need somebody who's kind of on the short side. Don't be shy. Okay, come on up. Thank you. All right, now I can actually see your kneecaps, so this will be easier. You are 19 inches to the middle of your kneecap. Would you guys write that down, please? And height is 64 inches. Thank you. 64 goes with, what did I say for the leg? 19. All right. Now, we just have to put that into our calculator. We will get this equation, which will tell us what? It'll tell us that, heaven forbid, if we were to find a leg bone in, like, buried in the sand, and then we could figure out how tall the person was, who that leg bone belonged to. It's kind of gruesome, but it actually happened in New York. They I don't know how the first body was found, but they found a whole bunch of bodies buried on a beach in New York. It turned out that somebody was killing prostitutes and then burying their bodies out on the beach. So if you're doing some forensics to try to figure out, what was this missing person, the person who, now they have DNA, so it's a lot easier to figure out based on DNA whether or not it's you or it was that person. But if you just measure their leg bone, you can get a good idea of how tall they are. All right, they have exact charts on this kind of stuff that they can use, but we're doing it with the calculator. All right, so let's show you how this would work. We got to put in these three sets of numbers into our calculator. So would you please get your calculator on, and if you don't have one, please borrow one from me, make it fast. And we're going to go to just a clean screen and hit the stat button. All right, move this over so the people at home can see this. I hit stat, that red one that turned red. I mean, it's not red for you, but all right. So do you see edit? We have to edit our data. So that's the very first thing we do is hit enter there, and we are going to edit our data. Now my data is different because in the last hour we were doing walleyes and their tails compared to their weight. Okay, well in this class we're doing heights and you're compared to your kneecaps or your height of your leg. So we're going on, the first number is 23. I'm just going to type over my old numbers. You could do that too, or you could hit delete to clear them off. 21 for this, 19 for that, and then I go to the other column and I type in 75 and 69 and 64. Okay, I've told my computer how long the legs were and how tall the height was, and now it's going to tell me an equation that I could use to represent the graph of the linear regression. Basically, it's a line that would fit that data the best, or a line of best fit. All right, so next thing is, after you got your data entered on the calculator, you hit stat again. See the stat button there? And now we've edited our list already, so we don't need to do that. What do you think we want to do next? Which of those tabs make sense? Edit, calculator, tests. Calculate. We're going to calculate something. Arrow over to calculate. Do you see something that looks like linear regression? Linreg, number 4. Linreg, ax plus b. The reason that ax plus b is there, it's telling you that's the style of equation it's going to give it to you in. There are some types of data that work better on a quadratic. There are some types of data that are, but this is linear. It's basically a straight line. And we're not going to make you do the more complicated ones till later. But for right now, this is just a linear or a straight line regression. So I hit enter. And it assumes when I hit enter that I wanted list 1 and list 2, just like I did it. If you ever want to switch that around, you'd have to do something more complicated. But if you always just put your data, the X goes in the first column and the Y goes in the second column, then this will work. Okay? You don't have to, this is the default. Okay, so this is my equation. And it says, and we've obviously never done this before because I just measured your legs, so this is brand new data. It came out pretty nice. It says y equals ax plus b. That's the form of the equation. And a is like the slope. So y equals 2.75x, 2.75x, and then plus 11.583 repeating. I have experience with this that you want to put in lots of decimals in there. Like, don't just cut it off and say, oh, it's 11 or oh, it's 12. Because if you round it a lot, then your equation isn't very good at predicting things. It's way off. So you want to include as much data as you can. Okay, so now I got this equation. How would you use this in the real world? Well, now I find a leg bone and I measure it and I can see how tall they are. Let's do that, except we don't have to actually remove somebody's leg bone. Who's willing? Come on, don't be shy. I just got to measure up to your kneecap. Come on, big chickens. Fine, I'll do myself. Okay, I'm going up to my kneecap. You got to help me look at it. Is it what is to the middle of my kneecap? What is it about? $21 to the middle? All right. So then I'm a wait a minute. If I'm a 21, I can even see that on the chart here. So I know that I'm going to be about 69 inches tall, and believe it or not, let's watch. Look at this. Can you read it? Am I about 69 inches tall? Mm-hmm. All right. Interesting, isn't it? Works. Okay. I'm going to call in you. Don't be shy. Come on up. I just need one more kneecap height. All right. So you are at 21. Dang it, we got another 21. So he's about as tall as me. All right. And is he exactly as tall as me? He's off a little bit, which makes some sense. Data isn't always going to be a perfect straight line. All right, so then I'll take the imaginary person. Okay, the imaginary person has a leg, and they're kind of short. Let's say it's a kid. So let's say that they're at 17 inch to their kneecap. I want you to figure out how tall they are. Use that little equation. It's on the board. Stick it in the right spot, and it's easy. You can tell how tall they are. All right. Generally, were the legs the x's, or were the heights the x's? The legs were the x's. Okay, these are the x's. So then, if I've given you a leg of, what did I say it was? 17. If I gave you a leg of 17, that means I gave you an x is 17, which means you put it right there. And now you have y equals 2.75 times 17 plus 11.58, blah, blah, blah. And what did you get? 58 about? If we round it, about 58? All right. Now let's show you how tall that is. 58 inches. Grab my tape measure here. So the kid be about this tall. Does that make sense to you? That seem about right? Okay. So you can see how this thing could be handy. You can correlate so many things. There's so many things that go together, like how wide your head is compared to how tall you are. Somebody isn't going to be really tall and have a really narrow head. It could happen, but it'd be an aberration. Okay, that is called a linear regression. I want you to go through the steps one more time with me. Everybody hit stat. Oh, I gotta clear my board off here. Hit stat. What's the first thing you do when you get a linear regression problem? You edit your data. And you go in there, everybody hit enter, and you go and you change these numbers a little bit. Okay, don't have to, but let's say we did. Then we'd go to where next? Stat again. And yes, calculate, over to calculate. And which one is it? Number 4, lin reg. And I hit enter again one more time, and it tells me the answer. And I didn't change my data, so I got the same numbers. Okay? That's how you do a linear regression. Now, what you've got on your problem is a whole bunch of years. Like in the X column, it's years. And then it's got not heights, it's got populations. And it'll tell you in what year it was this many people on the Earth, and on what year it is then, and then how many people were on the Earth. And you can use that to write an equation. And then you could say, for instance, you could solve for when will there be 10 billion people on the Earth. You can figure out what year it would be. Or if I say it's going to be year 2025, then you could tell me how many people will be on the Earth. Now, is it perfect? No, because we could have a giant contagion like that movie and have 1/10 of the world's population die from some nasty disease. It's happened before, but it's going to be at least where it would have been. It's like a projection based on the past about where we should be. So that's what linear regressions do. Okay, now your homework for today is right here, page 64. Write this down, please, because I won't have you up there long. Get a blank sheet of paper out to start your homework on. Page 64, 2 through 18 evens. Also number 28. And then the other page is page 42, problem 53. That's a linear regression question. We need you to practice that. I'm going to probably have you do some real-world data tomorrow where you do a linear regression where you are measuring your friend's, I don't know, length of their arm compared to their height, or I don't know, that kind of stuff. Just take 3 or 4 of your friends' data points and then make a linear regression for it. But for right now, all I have is page 42, number 53. That is your linear regression problem. You need to know how to do these. All right. And besides, they're kind of cool. You can use this in the real world. All right, now I'm going to, instead of making you take your books out, we don't have that much time left in class. I'm going to have you do, I'm going to tell you the first 2 problems, and then we're just going to do them together, and then you can leave your books in their backpack, and we'll have the last 5 minutes to relax. Okay, so let's do the first couple problems together. Number 2, write it down. Absolute value of 2x minus 1 is greater than 3.6. Now I'm going to split it. 2x minus 1 is greater than 3.6, and 2x minus 1 is less than negative 3.6. Don't forget to flip the sign. Solve both sides. You'll get 2 numbers. Did you get negative 1.3 and positive 2.3? Raise your hand if you did. Good. If you didn't, then you messed up something and look at the board, see what you messed up. Now, here is on the little number line. Do you have to do this? Yes, you do. It is a required part of solving these problems. You now have to figure out whether it works at those spots. Do you remember the tip I gave you about whether or not it's going to work at those spots? It will not work at those spots unless there's an or equal sign there. But there isn't. If you don't believe me, plug in those points and see, and they won't work. Okay, now I got to figure out, does it work in between them or on the ends? On all the other ones we did, it worked in between them. I think on this one, it's going to be on the ends. We'll find out. We'll try the number in between them, like 0. If I stick in 0, go back to the original equation, in this case, and stick in a 0. Do you see how I have the absolute value of negative 1, which is just 1, and it's 1 is greater than 3.6? Does that work? No, that does not work. So that's why it's not in there. Then you test a point over here. And then you test a point over here. When you're testing a point over here, you'll find out that it works. Like, say 3. Say 3. 2 times 3 is 6, minus 1 is 5. Absolute value of 5 is 5. And is 5 greater than 3.6? Yes, it is. So it works over here, and then it ends up working over here. And your final answer, though, isn't that. Your final answer is intervals, and this gets weird. This is one of the reasons I want to do this first one with you. Because the answer is not from 1.3 to 2.3. It's not like this, because it's everything except that. So how do I write that? You write it in 2 intervals. You say from here to here represents that interval. From negative infinity, good, to what? To negative 1.3. And the other interval that works in is from 2.3 to infinity. You get that? All right. And the only other thing, it's little, but it's important, is put a U between them. That stands for union. The union of this and this gives you your total answer. All right, there was problem 2. I'm going to just put problem 4 up on the board for those of you that want to get going on it. It's x plus 3 in absolute values is less than or equal to 5. It's just pretty straightforward. And then if you want to go farther, you'll have to take your book out, but we're getting close enough to the end that if you finish this, I'm okay with you being done. Don't forget to do that linear regression question. Those are going to come back. And they're really pretty easy if you get how to use a calculator.